Just want to give you a lecture for our part 2, chapter 8, temperature, heat, and thermodynamics. Okay, so there's one really key difference and contrast that you guys need to be aware of and to familiarize yourself with, and that is the difference between temperature and heat. And that's going to be the primary focus we have today. But we're going to talk about some other things like entropy and specific heat capacity to help you guys get a better grip on what we're talking about. All right, so let's begin with temperature. All right, so temperature. Temperature is something that we are very common we're familiar with. We think of temperature in Fahrenheit, right? 100 degrees Fahrenheit, that's hot, right? This week next week we're gonna have some 80s, which is hot. If you go to Arizona, it's in the hundreds. In the Middle East, in some places, you can get to like 120, 140. In Australia, in the center of Australia, right? So temperatures can get pretty hot, okay? But I want you guys to understand the temperature is a measure of the average of kinetic energies, right? So the movement of things, the movement of substances, right? The average of the kinetic energies in that substance would be the temperature, okay? Whereas heat is something very different, okay? But before we get into heat, let's look at some temperatures, right? So talking about absolute zero, right, on page 162, absolute zero is where all kinetic energy or all motion stops, okay? This is actually not obtainable because if you think about temperature as an average of kinetic energies, you cannot have what's called negative motion, okay? What do I mean by that? Well, I mean that an average of two substances, let's say you had 50% on your test and 100% on your next test, your average would be between the two would be 75, right? So how could you have an average of 0? If you had a 10 on one and a negative 10 on another, your average would then be 0. So if you think about temperature as its definition, which is the movement of kinetic energy, right? You cannot have negative movement. You say, well, Mr. Scribner, if I move backwards, isn't that negative movement? No, it is not negative movement. It is movement in a different direction, okay? So just because you're moving negative to where you're facing, it is not actual negative movement. There's no such thing as negative movement. So you cannot get to negative, because you cannot have negative movement, you cannot get to an average of 0, okay? You can get very, very close and very, very low, but you cannot get to 0, all right? And so when we talk about the average of kinetic energies, the scientific scale we use is called Kelvin, okay? So let's see, I don't think it says it on here. You've got like a little thermometer right here showing you, here you have like a little different of Fahrenheit scales, all right? Now, looking here on this chart, right, you have Kelvin temperatures, okay? Now, in order to understand what Kelvin is 273 Kelvin, right, is 0 degrees Celsius, okay? 273 Kelvin is 0 degrees Celsius. So if you look over here, it says, 0 degrees Kelvin is negative 273 degrees Celsius, right, is what it would be in order to get to 0 Kelvin, okay? And if you look down here, negative 273 Celsius is 0 Kelvin. I might have said it flipped the other way. Sorry about that. But what I was saying is if you add 273 Celsius and you get to 0 Celsius, then you would have 273 Kelvin. I might have gotten it right. Can't remember. But this is where ice melts. Okay? So here's 300 Kelvin. Here at 100 degrees Celsius, positive 100 degrees Celsius, okay? You can see that's where water boils. That's 212 degrees Fahrenheit. This is 32 degrees Fahrenheit, okay? Up here, 1800 Kelvin, iron melts, all right? Here, 600 Kelvin is the surface of the sun. 50,000 Kelvin, surface of a hot star. The center of the sun, 20 million Kelvin, okay? Meaning that the particles are moving extremely, extremely fast, okay? So when we talk about temperature, we are talking about the average of kinetic energies. It's very important to understand that. Kinetic energies are the movement of the particles within the substance, okay? And remember, absolute zero is not obtainable. Why? Because as an average, you cannot get negative movement. Therefore, you cannot have an average of zero, okay? If you have to listen to that a couple times, do so because it's very important to understand. All right, internal energy, okay? We're talking about the energy of the particles inside, okay? All the energies in the substance, okay? Now, if you want to increase or add energy to a substance, right, you want to transfer energy. This is not transferring kinetic energy. This is transferring thermal energy, okay, which will increase the internal energy that is called heat. So our definition of heat is the transfer of thermal energy, okay? So moving forward, heat, right? Cold is not actually something that exists, okay? Why? Because if we are talking about 0 Kelvin, right, that is the absence of heat or the absence of kinetic energy, all right, heat energy, that would be 0 Kelvin. You cannot get there. So cold would be negative, right? And we said you can't get negative, right? So technically there is nothing that is cold. Cold is just something that we use to relate to each other so that we can understand what we're talking about, okay? But as you can see right here, cold is not a thing in and of itself, but the result of reduced molecular kinetic energy, okay? So I want you guys to think about that. I like to always relate this to, my faith. If you think about, people say, why is there evil in the world? Well, there isn't actually anything that, there isn't such thing as evil. There is just a absence of good, okay? If you remove God, if you remove good from the situation, you're left with a result which people call evil or bad, okay? And, you can, we could debate that sometime, when we get back together, but I've, looked a lot into it, and, the Bible says that every good and perfect gift comes from above, meaning all the good things that we have in life, come from God. Whether you believe in God or not, we are all created in His image. Therefore, we are all given His goodness on some level. Okay, and so that is what I mean by the absence of God or the absence of good. If everything good or everything godly, everything of the Bible says God is love. Everything of love is removed from your life. What would be left? The absence of good, and that is what we as humans we call cold, the absence of heat. We call evil the absence of good. All right, moving on into the quantity of heat, right? So measuring heat, right? Heat is a unit for labeling food, right? We call that a kilocalorie, right? Which is 1,000 calories. So when you look on the back of your, bottle of soda or your Cheerios, you see, how many calories per serving, okay? That is the amount of heat that can be generated from the energy that is within that food, okay? So when we talk about the quantity of heat, we're measuring the amount of energy or the amount of heat energy that can happen from burning that food, okay? So when we talk about thermodynamics, we're talking about the study of heat or the movements of heat, okay? And there's laws of thermodynamics, right? For example, the first law of thermodynamics is stated that whenever heat is added to a system, it transforms to an equal amount of some other form of energy. What does that mean? That heat or energy cannot be created or destroyed. That is the first law of thermodynamics. The second law of thermodynamics down here, heat never spontaneously flows from cold to hot. For example, if you put ice in your hand, the heat is not going from the ice into your hand to make your hand even hotter and the ice even colder. No, your hand melts the ice. Okay, the heat is transferred from your hand to the ice, melting it. Okay, the third law of thermodynamics restates what we already know, the lowest limit of temperature, no system can reach absolute zero. Okay, that's the third law of thermodynamics. Okay, so this is also kind of like entropy, that things don't go from disorder to order, they go from order to disorder, the law of entropy. Okay, and so here's the law of entropy right here, basically saying that everything is going to tend toward disorder. In natural processes, high quality energy tends to transform into lower quality energy. Order tends to disorder. Now, the only way that something will not go to disorder is if it's acted upon by an outside force. So this is a great problem with evolution, is that we say, how did the origin of life or the origin of the universe come from, right? And so the thought is, well, if this is a law of nature that you cannot have anything go from disorder to order, how did things go from chaos into what we have now? And the answer is that there was an outside force that acted upon it. Now, an evolutionary scientist or philosopher would say that we don't know what that outside force is, but there had to be that outside force. But then you would ask, well, where did that outside force come from? Well, we don't know, okay? And so it takes just as much faith to say that there was an outside force that we don't know of, or to say that there was an outside force that we believe was God. He acted upon, and God has always been and always will be. Okay, he acted upon the universe, created the universe, and he created it with these laws so that we could see him, so that we could understand that, we didn't just evolve, we didn't just come from nothing, but that we were created because there was an outside force, and that outside force was God. Okay? Everything will tend towards disorder. If you leave a room and you come back 100 years from now, that room will be more disordered when you come back than when you left. And you say, well, what if nobody touches the room? Still, the walls will decay. The stuff inside the room will decay. Okay? Natural processes will tend towards disorder. Okay? Moving on to specific heat capacity. All right, so every substance has what's called a specific heat capacity. This is basically to say, like, how much heat can something hold? Okay? You can see right here, eating an apple pie, different parts of the pie hold different heat, right? The crust might not hold that much heat, but the fluid inside holds the heat, and so you might burn your mouth on the inside filling of the pie. All right? Same idea as if you were to, get burned with steam. Because water has a high specific heat capacity, meaning it holds heat very well, it's very difficult to cool yourself fast enough so the burns are generally very bad. Whereas if you touch a hot pan, you move your hand quickly, put it under water, and you can cool it off. The pan doesn't hold heat very well. It transfers heat well, but it doesn't hold heat very well. Okay? So talking about specific heat, all right, water has an extremely high specific heat, which is why when you live near a body of water, okay, like in this map, if you live, near the Mediterranean, if you live, on the shoreline, on the coast, your climate will be much more temperate, meaning that it will stay more the same because water doesn't change temperature very fast. It holds its heat. Whatever the temperature of the water is, holds its heat fast. Okay, you can see right here, as these rails heated up, okay, they got expanded, and eventually buckled. Okay, we call that thermal expansion, which is why on bridges, right, if you go across a bridge, you will see little teeth where, let's see if there's an example. You see little teeth in the bridge. So as it gets hotter, the bridge moves closer together. As it gets colder and it shrinks, the bridge moves farther away. Okay, that's called thermal expansion. Okay. Also, when you get out of the shower and your hair starts to dry, the inside of your hair might be cold, and the outside warm from the hot shower. The outside of your hair might get cold from the air, and your hair starts to bend like this, and that's what causes your hair to be curly. Not everybody has this. But for many people, this is the case. Okay, so you can see back on this picture, as water the ground will heat up faster than the water. Okay? So if you go surfing in the winter, the sand might be extremely cold because the sand changed temperature overnight very fast. But the water might be warmer. Now, vice versa. When in the summer, when it's hot, if you go on a hot summer day, the sand might be very, very hot because it changes temperature very quickly, meaning it does not have a high specific heat, but the water might feel cold, okay? Because the water will stay the same temperature. It will contain or retain its heat longer than the ground will, okay? Very important to understand specific heat. This is a measure of the amount of heat that things hold. This also has a lot to do with our calories, okay? Moving on, one incredible thing as we close, finish this lecture, talking about water. Water is a very, very phenomenal liquid, right? Water has what we would call a triple point, where there's a point of water where it can exist as water vapor, liquid, and ice. Okay, that triple point is where we call 4 degrees Celsius. Negative 4 degrees Celsius. No, I believe it is 4 degrees Celsius. Sorry. But I want you guys to understand water is an amazing thing, because if you look at this picture right here, you can see that the temperature outside is negative 10 degrees Celsius. Now watch what happens. For most substances, when they are solid, like if you're talking about liquid iron, it is less dense when it's liquid. It's more dense when it's solid. What does that mean? If that was the case for water, when water froze, it would then sink to the bottom. And then what would happen? You'd have layers of ice begin to build up, and then the pond would freeze solid, and all the animals inside would die. Okay? Now, what would happen at the poles, in the oceans? The water would freeze and it would sink to the bottom where it's colder, and then it would the ice would build up, and our oceans would begin to freeze up. Okay? But water has an incredible thing. The colder the water is, okay, right, it gets more and more dense, and as you can see in this picture, right, as water drops in temperature, it becomes more and more dense, right? But then as it gets down here at the bottom at 4, that's the most dense it can be, meaning it drops to the bottom at 4 degrees Celsius. But as it begins to get even colder, drops in temperature, right here we're dropping temperature, it begins to then again increase its density or volume. Okay, remember density is mass over volume. So the same mass will now increase its volume, therefore frozen water floats. Okay, without this changing graph of water's density by temperature, water, our entire lives would be different. It's literally a perfect scenario to make it so that water, ponds, animals in ponds and waters, and water is one of the only substances that acts in this way. Okay, so again, this is an example, a reason why I believe that there's a God. Why would water, the one substance that acts like this, why would it be water that acts like this so that organisms and things can survive in water? Why wouldn't all liquids act like this? And the reason is because God wanted to give us a hint or an explanation as to his existence, that this was specially created differently from all the other substances so that we can know that he created it and that it is not just evolved. All right? Very important to understand the terms, right? Temperature, understand absolute zero internal energy, right? The transfer of energy, okay? The transfer of thermal energy, the average of kinetic energies, okay? Thermodynamics is the study of heat and its transformation. First law, second law, third law of thermodynamics. Entropy, meaning that things go from order to disorder and not the other way around. And then lastly, specific heat capacity, the quantity of heat. And you need to understand how, the difference is, as I showed you here, that water will hold its heat, whereas the ground will not. Okay. This also, this is responsible for many winds and temperature changes, right? Because the water is warm or the water is cold, then the air and the weather will be similar. Okay, water affects the temperature nearby. All right. If you have any questions, please feel free to reach out to me. Let me know. Here's some example problem solving things that you can go through, talking about calculating the specific heat. The specific heat, right? Here's our formula. Q is the quantity of heat. C is the specific heat of a substance, which is a constant, right? M is the mass of the substance, and T is the change of temperature, right? You know, going from 25 degrees Celsius to 40 degrees Celsius, right? So like when you boil water, what is the heat that is needed? Okay, the quantity of heat that's needed to boil water, depending on the mass or the amount of water and the specific heat of water. Okay, so you might have the specific heat of water, the mass of the water, and then, you know, if your water's at 20 degrees Celsius and you need to get it to boiling, which is 100 degrees Celsius, how much heat is needed in the fire, in the flame, to boil that water? All right, so you can go through those, and then it gives you the answers after the solutions, so you can work through those. Please contact me, email me, text me, call me if you have any questions. Hope you guys are doing well at home, and look forward to seeing you guys again. Have a wonderful day, and I'll be posting your worksheets shortly, and yeah, later.